Okay, so good afternoon. Let's once again let's have a brief review of what we have discussed so far. We looked at the process of compounding and discounting and how they are related to each other. When we say compounding, we're getting the future value. So we use the formula future value is equal to whatever your present value is times the compound factor. Okay. And in fact, we plotted over time our future value. And we learned last time that the future value function is not linear. Okay, in fact, it's exponential. So the implication is that the more you prolong the maturity of your investment, the greater will be the returns. Okay, especially if it's if the compounding is more than annual, which we're going to discuss later. Okay, so we also learned how to make use of Excel's FB function. So here we computed for the FB, okay, sorry, FB function for the future value using the FB function. And we also learned to use the goal seek in determining, in this case, how long our money will double, okay, given certain parameters. Okay, so let's now, on the other hand, go to the present value calculations. Okay, so we'll just go do the reverse. Okay. This amount is coming from our future value. And then the question is, should we invest now? Okay, how much should we invest now so that we get 9.646 million after 20 years if the rate is 12%. So we can make use of, let's first make use of the formula. Okay, so the formula is okay. To get the present value, so PV is equal to your future value divided by 1 plus R raised to the T, or this is just the same as future value times 1 plus R raised to the negative T. Negative T. This one we call our discount factor. So the process of getting the present value is called discounting, while the process of getting the future value is called compounding. So let's use the PV function. So PV is equal to PV. Okay, the rate is 12%. I think we, okay, okay, the rate is still here. Let me check. So let's use so rate, okay. Excel function. Oh, wait, the formula first, sorry. So for the formula, it's equal to future value, okay, and then multiply that by, I'm using this, 1 plus the rate, okay, and then raised to, do you use ANPER? Yeah, we have ANPER. ANPER is 20 years. Okay, so that's our formula. So this is our future value multiplied by 1 plus the rate raised to the n per. Raised to the, sorry, it should be negative n per. So there should be a negative sign here. All right, so, okay, why is this wrong? Why did we use n per? Ah, okay. We did not use n per, right? So maybe we can, let's just use years here. Okay, so I'll name this one to be years. You recall the purpose of giving names to cells so that you can use those in formulas and it enhances the computation. Okay, here, years, there. So let's try this, I'll enter. Okay, so we expected to get 1 million, okay, because this is just the reverse. So given 9.6 million after 20 years at 12% interest, how much is the money equivalent to now? So that's 1 million. Okay, and in Excel function, like we use PV and rate. The rate is, you can use the rate object, comma, n per is years, right? Comma, it's not a PMT, it's not an annuity. The future value is this amount. Okay, the type you can ignore, okay, because this is not an annuity. All right, so control enter, and then we get a negative 1 million because our future value is positive. Therefore, our present value should be negative in terms of Excel. So let me just put negative there because we're not interested really in the direction of the cash flow. We're just interested in the absolute value. Okay. So a few, okay, let me show that. And when you're done, kindly chat please in the chat box, yes, so that I know if you're able to already, let me first, sorry, let me, to help you, a formula. Okay, so that you can see what formula we used. Okay, thank you, Carlos. Was that your answer? So if you're done, class, if you're done using the formula and the PV function, kindly chat yes, so that I know if you're okay already. Okay, let's wait for your classmates. Okay, any questions, class? Clear so far? Okay, no questions. All right, let's proceed. Okay, so we go to annuities. We said last time that annuities are uniform stream of cash flows. Okay, for example, this is an annuity. So it's an annuity of 2000. Okay, annuities can, of course, be, it can be mixed with other cash flows. So for example, if you have, at the end, you have 3000, okay, we can still consider this as annuity by breaking down the 3000 into 2000 and then a 1,000. Okay. That way, you have two types of stream of cash flows. You have an annuity of 2,000 and one future value of 1,000. All right. There are two types of annuities. One is annuity ordinary, where the cash flow begins at the end of the period. Okay, so let's say you borrowed money here at the end of the first, whatever is the scheme, whether it's monthly. Okay, you borrowed a certain amount. At the end of the term, you start paying. So that's what we call annuity ordinary. Usually loans are of that type. And another one is annuity due, where the cash flow begins immediately at the beginning of the period. This one is at the end of the period. So it's the same amount in our example, 2,000. However, the timing is different. So what's different is that we have a 2,000 here at the beginning and nothing here. On the other hand, for ordinary, we have a 2,000 here at the end and nothing at the beginning. So these cash flows are just the same, they're equal, but the only difference is that for ordinary, there's a cash flow at the end. For annuity due, there's a cash flow at the beginning. Okay, when you're solving problems and it does not specify whether the annuity is due or ordinary, the assumption is that always it is annuity ordinary. Okay, very good. All right. So, okay, this is quite a long. This is an example of another example of annuity ordinary and annuity due. This one is annuity ordinary. You have a stream of cash flows, one for the next 30 years. Okay. And on the other hand, this one is annuity due. You have one beginning immediately and then up to year 29. Okay, but if you count those cash flows, those are 30 cash flows, just like this one. Okay. Now, the problems here are usually find the present value or find the future value of this stream of cash flows. Okay, sorry, I bit my tongue. Sakit. Okay, so there are different ways to do this. Okay, did I give you this one, plus? Do you have this?
Yes, sir.
Okay, I was not supposed to give you the answer here. Okay, but anyway, it's here. So what did I do here? We cannot just add, of course, the cash flows because they belong to different time frames. So how do we know, for example, the equivalent present value of an annuity ordinary or an annuity due? So it's actually very easy. It's just conceptual. So here, what we did here was to compute for the present value of this cash flow of 1. Okay. How much is this at year 0 now? Okay, so you do everything and you compute for all this in different cash flows at different time frames. You compute their present values. So why don't we just delete this? Let's just do it on our own. Okay. In fact, you can just delete this. You delete the present values and I was not supposed to give this to you. We were supposed to do this on our own. Okay, so let's use the PV function, negative PV. Okay, present value. And then what's the rate? The rate is also 20%. So let's use the name that we gave to it. Rate is, 12%. No? Rate is 12%, then comma. What's N per? You have different cash flows here, and each of these cash flows have different periods, number of periods. For the first one, it's N per 1, and we don't need to copy to fix this because we're going to copy this formula to the right. okay, and comma PMT. Okay, so what we're doing now is we are not regarding this as an annuity. We're first regarding this cash flow as individual. Okay, we're not going to solve this as a PMT, as an annuity, but rather as single cash flows. We're going to get the present values of each cash flows. So ignore the PMT, and the future value here is 1. Okay, and then ignore the type because we're not treating this as an annuity. So let's close this. Okay, is there anything here that we need to fix? We're going to copy the formula to the okay. Is there anything we need to fix here? No need. Okay, thank you, Luis. Yeah, you're correct. Nothing to fix here. So Control Enter, and I get 0.89. So what does this mean? Let's 0.89 is the present value of a cash flow of 1, which after 1 year, in 1 year's time. Okay, so we can actually copy this formula to the right. So let me copy it to the right. There. And you notice that the present value over a longer period is, of course, becomes less, no? Becomes smaller. That's indicative of the concept of the time value of money. We would want our money to be, let's say, to get, if we're going to get it, we want it to be closer to the present value. Okay, closer to now. You can see the that the present values of future cash flows becomes lower. Okay, so this is just the sum. Okay, we just summed up all those present values. We can do that now because these are now all present values. Okay, so we can now sum up all these present values. Okay, and we get 8.06. So that answers the question. If you have an annuity of 1 for 30 years, annuity ordinary, then it is equivalent to 8.06, assuming that the interest rate is 12%. Okay, let me pause for a while. Let me give you a chance to catch up with what we're doing. Okay, and when you're done, kindly chat, please, if yes. If yes, if you were able to get it, if you were able to follow. I hope you erased the present values. Okay, let's wait for the others. Let's give them a few more seconds. Okay. Any questions? Gerard, are you okay? Gerard?
Oh, sorry. I think my caps lock was on.
Okay. It's okay. Are you okay? Okay lang, were you able to follow?
Yes.
Okay. Julian, okay. James, Kathleen, okay. So I think everybody's fine. Okay. So what we can do also is to use, oops, let me, okay. We can use directly the PV function. Let's delete this, please. Okay. Let's delete this and get the present value using the annuity itself. Okay, so it's equal to PV. What we did here, as again, let me explain, is that we got each of the present values of these cash flows, and it's now we're now justified. We're now allowed. We can now add these cash flows because they are now all present values. Now, a shorter formula without getting the present values of each of the cash flow is to use the once again the PV function and make use of the annuity, this one. But we have to make sure that this is indeed annuity. It should be a uniform stream of cash flows. So the rate is, let's type rate. Okay, comma. What's our NPER? Our NPER is, in this case, it's a different problem. So it's 30, right? 30 years. Our first problem had 20 years. Then comma. Now we can use PMT. Okay, so it's an annuity of 1, right? Okay, and then comma. Is there any other cash flow aside from this one? Because I said a while ago, we can have a cash flow at other periods. For example, if at the last period the cash flow is 10, then it's actually an annuity of 1 and then another 9 here. So we can put in our formula a 9 at the end. Okay, so there's no future value. And for the type, so let me just ignore that. For the type, the default is always at the end of the period. Okay, so this is at the end of the period, so I can type 0 or I can just ignore that. But let me just type 0 for us to be guided. Okay, and I expect to get a negative answer here. So I'm going to put a negative here in front. Okay, and we get exactly the same answer. $8.06. Okay, pause again. Let me pause for a while and let me ask everyone to give me feedback if they were able to get 8.06 using the PV function of Excel and using the fact that we have an annuity. So we replaced the PMT with 1. Okay, I'll wait for your feedback if you were able to get it. Let's wait for the others. I think everybody got it.
Sir, can I ask a question now?
Yeah, sure. Go, please. Yeah, please.
Can you explain again, sir, why using the PMT formula we don't need the future value?
Sorry. Here,
Yes, sir.
this one, PV.
Yeah, yung concept lang po, medyo nalilito ako.
Okay. Sige. The problem, what we want to do, what we want here is that we want to get the equivalent of this stream of cash flows, a cash flow of 1 for 30 years. Okay. So we have here 30 years. Each year you're going to get one peso, for example. And it's an annuity ordinary because this is year zero, time 0. After 1 year, that's when you get 1. Okay, the question is how much is the equivalent of an annuity of 1 for 30 years, earning 12%? How much is its present value? Okay, so the first method that we used was to convert each one of them. And we converted this one, we converted it to its present value. How much is 1? How much is 1 peso, which will be received after 1 year? And with the interest of 12%, how much is it now? The answer is it's equal to 89 centavos. So currency, after 2 years, it's 80. After 3 years, it's 0.71. So now these are all present values. So we can now add them all because they're all now present values. And what we got was 8.06. Okay. However, that's the longer method. We can actually dispense with getting the present values of each of the cash flows and make use of the fact that this stream of cash flows is an annuity. Okay, and in Excel the annuity is PMT. Okay, so let's run that. Let's get the present value. Okay, the rate is, let's use the name that we gave it, rate. Okay, comma, and per is, okay, we did not write a cell with 30. So let me just link it there, 30. Okay, comma. Okay, this one, PMT. What's PMT? PMT is annuity. So is this an annuity? Who's one asking the question?
Opo, si Jillian, sir.
Jillian, sige. Is this an annuity? Itong 11111 na yan, annuity ba siya? Ito. Jillian?
Yes, sir.
Yes, it's an annuity of how much?
Yes, sir. It's Annuity po.
Annuity of? Hello?
Of
Unstable
one.
yata. Yeah, annuity of 1. So here in PMT, I'm going to link it to 1. Okay? And then comma, future value. Meron pa ba tayong future value? I mean, is there any other cash flow aside from 1? If, for example, is there a future value here at the end? Kasi pwedeng 11 to eh. This can be 11. So if this is 11, we can split it into an annuity of 1 for 30 years. And then we have here at the end 10. Diba? After 30 years,
Yes.
10. So yung 10 na yun, we're going to put it sa future value here.
Oh, okay, okay.
Okay? But there's no other cash flow there. It's just an annuity of 1. Okay? So we can just ignore that, comma, and then yung type natin, this is annuity ordinary, so it's end of the period. Okay, so we can type 0, or we can just ignore that. In fact, we can end up to S15 here. Kasi panay zeros naman the two following figures. Okay, but anyway, I'll just leave it blank, leave it there, and then close this, Control Enter, and I'm getting negative. So let me just put a negative sign here. Okay, so it's 8.06. So same. We were able to validate that indeed the present value of a stream of an annuity of 1 for 30 years at 12%, it's equal to 8.06. Okay?
Yes, sir. Clear na po. Thank you.
Okay, sige. Thank you. Now, I'll give you 2 minutes, class. This time, okay. Let's delete this first. So get the present values of each of these. And let's add it here to get the present value of an annuity due. Notice what's the difference between this one and the one above. This one is an annuity due because it starts immediately here. It starts at the beginning of the period. So the one above it's an annuity of 30 years. This one also 30 years. But you can see here that there's no more cash flow at the end because the cash flow started at the beginning of the year. Okay, so may I ask you to compute now this one using PV and then add it here, and let's see how much is the present value of an annuity of 1 of 30 years at 12% if it's annuity due. Okay, If you're done, kindly chat. Let me pause recording first. So let me flash my screen here. I'm getting 9.02. Okay. All right, 9.02. That's correct. Right. This time here, use the annuity, use the PMT instead of just getting the present values of each. And try to see if you get also 9.02. I'll give you a few seconds for that. Same. Okay. Can you share your equation, Luis? Can you share your formula here? Okay. Absolute PV rate, AB21. Okay. About the others, did you get also 9.02? Using the fact that this is an annuity, so we can make use of the PMT input there in the formula.
So how did you get like the 1.0 in there?
Here, this one.
Yeah.
Okay. So let me show the computation. Okay. So this one, we're getting the present value. So present value of using the rate, and then R21 is your cash flow, okay, comma. It's not, we're not treating this as an annuity. We're treating this as a future value. So annuity none, and then our future value is 1, the cash flow above. And then we ignore the type because the type is only for annuities. We're treating this as individual cash flows. Okay? And nothing to fix there. We can copy the formula all the way to the right to year 29. Okay, did you get the answer?
Oh, okay. Yep.
Okay, then copy to the right, and then we can add it here. The sum of only until 29, okay? not including 30, because this is annuity due. Cash flow begins immediately. Unlike this one, the yellow one, cash flow is at the end of the period. Okay. All right. So for this one, we can make use of the direct formula. So it's negative PV. Okay, and then rate. This one is N per is 30 years. Okay, and then this one is PMT. What's PMT? 1. Okay, we're using 1 because we know this is an annuity of 1. Okay, and then no future value, no other cash flow except the annuity. And then this one is crucial because if you don't put anything here, it will be just like annuity ordinary. So you'll get the same answer as 8.06. But this is annuity due. Okay, so the type should be 1, which means at the beginning of the period. Okay, so if we perform this, 9.02, we get exactly the same. Okay, may I ask everyone please to chat if they were able to get the both answers, and please feel free to ask if you have any questions. Okay, were you able to get it? Okay, thank you. We're waiting for the others' response. Yes, yes. Okay. Okay. All right. Please feel free to ask questions. Okay, don't be ashamed to ask questions. Okay, thank you so much. All right. Now, let's review what we have discussed so far. What we used. One method that we use to get the present value of an annuity is to convert each of these cash flows into their present values and to add them. And this can be quite unwieldy, especially if you have a long term. If it's only a few years, then it's okay. But we said that there's a shortcut because we can make use of the fact that this cash flow is an annuity. Okay, so what we did was to consider that and then input that as PMT equal to 1. So we were able to get this. Okay, so there's another function that we can use here. Let's use this function NPV. Okay, I'll give you 1 minute to try using the NPV function, because the NPV function is just like getting the present values. Net, which means getting all the present values. Okay, so kindly try is equal to NPV. There. I'll give you a few minutes to see if you'll get 8.06 here. And also here, use NPV also to check if you'll get 9.02. By the way, before you do that, notice that the present value of an annuity or due will always be bigger than annuity ordinary. 8.06, 9.02, because cash flow here immediately is obtained. Okay. The cash flows here are both the same for years 2 up to years 28. Okay. Yeah, 29. The only difference is that for annuity ordinary, we still have a cash flow of 1 here. For annuity due, we don't have it here anymore because it was loaded at the beginning of the period. Okay, since we're getting the present values, the increment now is what's the present value of 1 after 30 years, which is 0.03, versus the present value of 1 now, which is 1.
Okay, so that's why we expect the difference to be 1 minus 0.03, so around 0.97, okay, approximately. Okay, so now use the NPV function in order to compute for the present value of this annuity ordinary, versus this annuity due, annuity of 1. Okay, I'll give you a few, 1 minute, please. If you're done, kindly copy your formula, the formula that you wrote here, and then paste it in the chat box. Okay, I see an answer here. Okay, Luis. Okay, let's wait for the others, Luis, to key in their answers. And then I'll request you to explain how you got your answer. I'll request you to share your screen. Let's give your classmates a few more seconds. Okay, Carlos, thank you also. Okay. Okay, how about the others? Okay. James, your formula. James, I don't see your formula in the chat box. Okay. All right. It's okay. Okay, so let's see. I'm giving you permission to share your screen. So let me stop share. Okay, Luis, could you kindly share your screen and let's see, explain to your classmates how you got the 8.06 using the NPV function.
Okay, can you see my screen, sir?
Yes.
Okay, so ito lang. I
Kindly
got
Pwedeng paki-increase yung ano.
Sorry.
Yan, sige.
Okay, so I got the rate from na ano na yan, named range. Tapos I highlighted yung payments per period.
Okay.
So which is this one, yung annuity ordinary row.
Yeah.
So syempre one
Yes.
per period hanggang I think this is 30.
Yeah.
Yeah,
Yung
30.
dulo. Oo.
So yan, automatic na siya na mag-calculate. Just have
Okay.
to name the range.
Yes, correct. So that's good. How about dun sa ordinary annuity?
Same thing, sir. Just you have to move it lang kasi it's gonna start at the zero period.
Okay. Pero the answer
Actually,
is
mali nga to. Sorry.
oo nga,
I don't know.
8.02.
I wasn't able to get it.
Oh, dapat 9.02 ano? Sige, very good. Okay, so so James, si Luis is correct as far as the annuity ordinary is concerned. Okay, let me share my screen. However, okay, dun sa annuity Juna, ang lumabas yung ano din, yung same answer as annuity ordinary. Okay, so let's do this. Is equal to NPV. Now, it's important for us to understand how the function works. So let's read first, before we write the parentheses, let's read what is required for the NPV function. So it says here, returns the net present value of an investment based on a discount rate and a series of what? Series of what? Everybody, please. Series of class. Series of what? Ito.
Future payments and
Yeah, future
income.
payments. No? Future payments. Okay, so yung NPV function ni Excel, ang paggamit dapat yan, future payments. Okay, so basta alam natin na future payments, ha? Okay, rate, we use the rate name. All right. And the values will be, ang sabi, future. No? Future. So ang future natin ito, year 1. Kasi yung now, ito di ba? So ang future natin, this one. Okay, highlight natin lahat yung mga future, di ba? Yan. Mga future yan. Alright? Alright. So, okay. Wala na, no? Rate and then the values, the cash flows. Close natin, and we get 8.06. Okay, now for this one, okay, is equal to NPV. Okay, rate is rate, comma, future. So dapat dito ang cash flows ito. Future, it should start with year 1. Okay? Highlight natin. Okay, wala na naman dito. So hanggang dun. Alright? Then, what's missing, class? What's missing?
You have to add 1 at the answer.
Yes, we have to add this kasi this is part of the cash flow, but it cannot be used with the NPV function because the NPV function tells us that it should be future cash flows. Okay, so we start with year 1, which is the start of the future. Okay, and then we have to include this. So plus this one. Okay, we can add 1 because this is already present value. All right. So try please and tell me if you got 9.02. Okay, unmute yourselves and tell me, just voice out if you got 9.02. Don't have to type. So feedback, please.
Yes, we were able to get it po.
Okay, thank you. How about the
Got
others?
it.
Okay, good. Thank you. Yung iba?
Okay po.
Okay, good. Waiting for the others to give their feedback. Unmute na lang. Okay. Chinat nyo, no? Okay, sige. All right. So that's how you use the NPV function. Okay, remember that because we're going to use that extensively in this subject, the NPV function na yan. Because it's really the easiest. Okay, unlike this one, number one, this one is the most unwieldy because you have to convert each of the cash flows into their present values. This one is okay. We recognize the fact that it has an annuity of 1. This one, class, this function is the most versatile because we can highlight cash flows whether they're annuities or not. So it can be a different stream of cash flows. It can be not an annuity. Whether it's an annuity or not, it doesn't matter. You just highlight those cash flows and then it will give us the net present value. Okay? Just be aware of the fact that the NPV function should start with the future, it should include only the future cash flows. So that's why we need to add back the cash flow at year 0. Okay, any questions so far about this this explanation about the annuity ordinary, and annuity due, and how we can solve that in Excel? All right, so thank you. Okay, so let's use those things. Okay, here we have the formula for, okay, so this is the, okay, no, this is the formula to get the annuity itself. Okay, this is the formula to get the present value. All right, so kindly, you have this problem, 30,000 payment refers to annuity. This is our annuity. Okay, 30,000 per period. Okay, let's just say it's per year. Interest rate is 10%. Okay, number of payments is 30. So get the present value if it's an annuity due, present value of an annuity ordinary or annuity due. Use the PV function. Do not use the NPV function. Okay, because to use the NPV function, you will have to plot out the 30,000 for 30 years. Okay, so we just use the PMT function and then use the formula, this one. Okay, so 3 ways to do it. Let's compare if we get all 3. Okay, I'm sorry, we will compare. This is annuity ordinary. Let me put this here. Okay, so let's get the present value using the PV function and using the formula. And then what if it's annuity due? Okay, I'll give you once again a few 1 or 2 minutes. Okay, when you're done, kindly just shut the first. Okay, no, don't shut it. Huh? We'll just compare notes. I'll just ask you to chat yes if you're done. Okay, and let's wait until everyone is finished, and that's the time I'll ask you to copy and paste your answer. Okay, let's go, class. Let me pause again. Okay, I'm getting, for the present value of an annuity of 30,000, earning 10% interest for 30 years, the present value is 282,807.43 for me. Did you get the same answer, class?
Yes, po, sir.
Okay, so let me copy the formula here. It's equal to formula text. Okay. So this is the formula that I used. PV of, it's PV. The rate is 10%. The number of periods is here, 30. And the future value, the PMT, PMT is 30,000. There's no future value, and ignore the type because this is an annuity ordinary. Okay, so this is the formula using the PV function. And 30,000 for 30 years at 10%. Okay, the equivalent value of that is 30, no? 30,000. Now you might be thinking, but parang ang liit, ano? Kasi 30 times 30, that's 900, eh. Diba? If we just multiply 30,000 times 30 years, that's 900,000. But remember, you just don't add everything. You don't add 30,000 for 30 years because that will violate the time value of money. If we go here, okay, and then let me replace 90,000. I replaced, okay, I replaced 1 with 30,000. Okay, so let me remove the decimal places. I'll copy this here. Okay, so I changed everything. Oops. This is wrong. It should only be 30,000. All right, 30,000 for 30 years. Okay, and the rate should be, I think the rate that we used is, okay, the rate should be 10%, no? If I replace this by 10%, we'll get the same answer. 282,807. Okay, did we get the same answer? Yeah, 282,807. Okay, so let me go back to the original. Okay, questions, class? Were you able to get this? Did you get 282,807? This is the formula. You can follow this formula. Okay, thank you. It's good. About the rest, class? Okay. Waiting for the rest to. Okay, good. Okay. Now, how about the formula? Okay, so this is the formula. So let me also copy the formula here. All right. So this is the long formula, the mathematical formula. So it's P, this is your P, this is your annuity, B31 times 1 minus 1 plus R raised to the negative N close divided by R. Okay, kindly do that. Of course, the first formula, the PV function, is a lot easier. Okay, then you should be getting the same because the PV function of Excel is, of course, based on the formula of getting the present value of an annuity. Okay, and this one, okay, the only difference between the first one, the present value, if it was ordinary annuity, and this one, if it was annuity due, is that we qualify it to be annuity due by including 1 at the end. Okay, so we expect that the present value of annuity due will always be greater than the present value of annuity ordinary, because you have a cash flow that immediately happens, okay, at year 0. Okay, once you're done, class, with both, kindly chat again, please, so that I know you're able to follow along. Okay, good. Okay, let's wait for the others. This one is quite confusing, no? Kasi marami siyang mga parentheses. But just follow the formula, okay, and then you'll be fine. Okay, so that's how we, thank you so much for your feedback. That's how we get the present value of an annuity. So we have learned so far how to get the present value of an individual one cash flow versus the present value of a stream of cash flows in the form of an annuity. So if we get the future value, so this will be very easy also. Okay, so let's use the future value to get the annuity is equal to negative FB, just to cancel out the negative sign. The rate is 10%, NPER is 30 years, PMT is 30,000. Okay, no present value. Okay, type 0, end of the period. Okay, control enter. So we get 4.934 million. That's the equivalent future value of an annuity of 30,000 for 30 years earning 10%. So also, okay, also we can make use of this, the fact that we can make use of the fact that this annuity is equivalent to 280,807 now. So these are equivalent values. The annuity of 30,000 for 30 years, 280,807 now, and 4.934 after 30 years. They are all equivalent values. In other words, we are indifferent to any one of them, assuming that the interest rate is 10% and the number of payments is 30 and the annuity is 30,000. So we can use the FB function. The rate is 10%, comma, NPER is 30, comma. So let's not use the PMT, but rather let's use the PV. So this is the PV. Okay, so this time let's convert the present value, okay, into its future value. We'll get the same answer because this present value actually came from this annuity of 30,000 for 30 years. So we're just getting the equivalent value. So I expect 4,934. Okay, there, it's the same. 4,934,820.68. Okay, now it's important for us to understand that because we have to understand that these are equivalent figures. So if I ask you which is better, assuming that the rate of return is 10%, which is better, getting 282,807.43 now, or getting 30,000 for the next 30 years at 10%? Theoretically, the answer is it doesn't matter. Okay, they're both the same, they're equivalent. Okay, as to the choice of which one, let's say you're given that option to choose any one of them, it will have to depend on other factors, but not the numerical value, because they're all equivalent, they're the same. So as I said, we are indifferent to choosing between 280,807 now or 30,000 for 30 years annually at 10%, or 4.934 million after 30 years. Okay, so as I said, these are equivalent values, and if we're asked which of them is better, you say that all of them are the same. Of course, assuming that the rate of return is 10%. Okay. All right. Okay. How about this? I think kindly delete the answer here, please. You should not. I should not have given that to you. Okay. This time we're given either 282,807. This came from the present value there, or 4934, the future value. 30 years and 10%. How much should be the annuity payment? Okay, assuming annuity ordinary. If we want the equivalent of 282 or 4934. Okay, and we know the answer here should be 30,000. But let's compute for that. So we will use both control. And let me put this below. So this is the formula to get the PMT. Okay, PMT, if we know the present value. Okay, so you use the Excel function and use this, and let's compare. And we expect the answer to be 30,000. Okay, James, formula saan, James?
Sir, dun po sa future value po kanina.
Future value, sige. Okay. So let me formula text. There. Ito yung ginamit natin yung present value.
Thank you, sir.
Okay. So yeah, thank you, James, for the question. Class, don't be ashamed to ask questions. Okay, so we're now here. So use this formula, mathematical formula, to compute for the payment, and use Excel function to compute for the annuity. Of course, we know the answer is 30,000. Okay, I'll give you a few seconds. So we expect to get 30,000. I'm getting 30,000 for both. This is the formula. You get it, class? Okay, thank you. All right. For those who were not able to get it, let me flash the formula. Control C, Control V. Okay. So we have here PMT. Okay. When you're looking for the annuity, we use the function PMT. Okay, and the syntax is, I'm sorry, here. The syntax is the rate, that's 10%, and then N per is 30, okay, and then PV is 282. Then there's this FB here, which we should not use because 4934 million and 282, they're just equivalent cash flows. They're not different cash flows. They are equivalent cash flows. Some students make the mistake of including the future value. So if I include the future value here, okay, what do we get? We'll get 60,000 there. Because it presupposes that the 282,000 now and the 4934 after 30 years, it presupposes that they are distinct cash flows. They're not distinct cash flows. These are equivalent cash flows. Or I could have solved this also this way. I did not put anything in the present value. I placed something in the future value. Okay, I'll get also 30,000. Yes?
So is there a reason like why we didn't put that 282,807?
Where?
It's like I think we left the PV blank.
Initially, that was what I used here. There. That's what I used. Okay? So take note, class, that, okay, where's my pen? We actually have only one cash flow. Okay, the cash flow is, sorry, the cash flow is, it's an annuity. 30 years, okay, 30,000 each year. 30 until the end here, 30. Okay, and what we did was we got the equivalent of 30,000 for 30 years at 10%. The equivalent of that is today it's 282,807, right? And another equivalent is 4.934 million. 4.934 million. 4.934 million. So these are equivalent to an annuity of 30,000 for 30 years. So if I want to compute for 30,000, okay, I should not use both. Otherwise, I'm saying that they are not equivalent cash flows. Okay, so how did I compute for 282? I computed for 282 using this cash flow. Okay, therefore, if I want to compute for this cash flow, for this 30,000 for this annuity, either I use 282 or I use 4.9 million. You cannot use both. Okay, that's why when I use both, okay, let me, so take a look at this one. Negative PMT, rate is 10%, N per is 30, and then here I'm using PV. Okay, if I use PV, I cannot use anymore, I cannot use FB anymore, right? If I use FB, the answer will become 60,000. But we know it's not 60,000, it's supposed to be 30,000 only. Why? Because you use the equivalent cash flows. Okay, as I said, we can use the PV, this one, it will give us 30,000, which is correct. Or we can use not the PV, so comma, let's use the future value, this one, 4934. and we will get the same, 30,000. So whether we use the PV of 282 or the future value of 4.9 million in order to solve for the annuity, you'll get the same answer. Why? Because they are equivalent cash flows. Okay. Who was the one who asked?
Oh, that was me, sir.
Gerald? Okay. Did that answer your question, Gerald?
Yes, thank you, sir.
Okay, good. Okay, good. All right. So, okay, it's already time, and this might require some longer computation. Okay, so let's stop here. Okay, let me